Week in review. This week we covered logics. We talked about George Boole and his background. So he was a mathematician who had the insight at that time to simplify mathematics to zeros and ones. He did not have formal education. He published some papers, received a very prestigious Society Royal Medal, but his most important work were the math analysis of logic and the laws of thought, books he published in 1847 and 1854. He passed in 1864 of pneumonia, and it was about 80 years before researchers made the connection between what he had found and discovered and published to computers and information and zeros and ones. So that gentleman who made that connection was Claude Shannon, University of Michigan grad and MIT research student. What did he discover? Well, he simplified things. So Boole said we can have math as symbols or algebra represent 0 or 1 or false or true, either or. And from there he said, well, if we want to compare two expressions with and, then as long as one of them is true, one of them is false, then everything is false. Both of them have to be true. And for the or, it was the opposite. At least one of them has to be true for the expression to be true, and if both are false, then it's false. And not means negate. So if it was false, then it becomes true, and if it was true, it became false. To make the connection to C++, we have the symbols for and, double ampersand, for or, double pipe, for not, the exclamation point. And then we can also create Boolean expressions with greater than, less than, equal, greater equal to, less than equal. So from here, we went ahead and talked about the conditional structures in C++. So an if statement requires a Boolean expression or something that evaluates to true. And if it's true, then this block executes. From there, we said, well, we can also have an else. So if it's false, then this block executes, and the else does not have a condition. From the else, we can also, from the if else, we can also expand to an if else if, and this else if branch can have one or more branches. So a branch is from here to here, right? An else if. BE stands for Boolean expression. So we require a Boolean expression here, and again, else is the fallback if nothing matches. Afterward, we covered the switch statement, which is another way of comparing things. However, we require an integer here, something that evaluates to an integer. And we can say, if the value of this variable is 1, execute this code afterward break. If we omit the break here, this code executes, followed by this code execute, and finally it breaks. Thus, we have to be careful with breaks. If you just want this block to execute, then don't forget the break. If you want the 2 to execute, then go ahead and omit one break. The default, we understand, and we found that it works like the else. So let's not forget that. So in this case, like if our choices for this variable are not 1 or 2, then this piece of code will execute. I didn't talk about the immediate if, but this is a shortcut if, and I'll talk about this in class, okay? So I'll create an example for this. From there, we jump to going over some simple examples using Boolean expressions. And my whole point there was understand the truth table. So if you understand ands and ors, then you can create sophisticated Boolean expressions with the knowledge of those truth tables. And you don't have to be guessing. I said and or if, or what do I do? So that was my whole point there. order of precedence, we know that not takes precedence, then and then or. We talked about the while loop. So the while loop takes a Boolean expression and it'll loop as long as the Boolean expression evaluates true, true. Again, in a while loop, we have to have some code that eventually makes this Boolean expression false, which stops the loop. The loop is a pre-test loop, meaning we test first and execute afterward. Also, we don't necessarily know how many times a while loop will execute. Now the for loop is a little more involved. So we have variable declaration here. So we declare a variable, we initialize it, we create a Boolean expression with a greater than, less than, equal to, and then on the third step, we increment, decrement. We have to make sure that we understand that there's no semicolon here, there's no semicolon here. Also notice no semicolon over here, okay? And usually for the for loop, we do know how many times it will loop, okay? So mainly because we loop from some number to some number, okay? And we increment. Unlike the while loop, the increment, decrement is done in here. And then this code block would execute. We covered the do while loop. Now the do while loop executes at least one time. It executes one time. In the loop code, we must have code that changes the Boolean expression to false. Either prompt the user if they want to continue, check the Boolean expression, and if it's true, continue. If it's not true, exit. Notice semicolon. This is the only time in a while loop, and this is in the do while loop, that we have a semicolon at the end. This is required. Also notice that the while piece is outside the code block. Do not forget that. You also have an assignment this week that will give you some practice with if, else, if, and switch. So you will implement this table. So you have this range, 90 to 100 is A, and likewise for B, C, D, and F. You have to create a function with an if, else if, accept the number, and return a string. Notice a string, not a character, okay, a string. Make sure you pay attention to this. And this should be straightforward. The switch may or may not be straightforward. You do have to implement this same table with a switch. So as we understand the switch, originally it did not have the ability to compare ranges. Now it does, but you have to go do the research on Google. That's one way of completing this function. The other way is by doing some math. So if we use math to reduce this to single digits, then our switch statement becomes a lot smaller for the comparisons. And just remember how to use the break statement to execute or not execute the next statement. You do have to create the function code, then the test case, and finally in main. Just follow the instructions here for you. As for the readings, we want to make sure that you read chapter 6, that's about looping if you haven't already, and then also read chapter 6, that's functions. We will get into functions. Chapter 6 in the 10th edition guide is, or 9th. If you're using the free book for the functions chapter, read chapter 9. Okay. I think that's it for the weekend review. Thank you.